So in this video, I'm going to look at the next type of reaction, which is single replacement reactions. In a single replacement reaction, one element kicks out another element in a compound. So for example, if you have the element A and it reacts with a compound BC, if that is a metal, meaning when it's an ion, it has a positive charge, it's going to kick out another positive charge. And so B would be kicked out, so it's by itself, and then you'd have AC. Now, the other type of reaction, what if, for example, so instead of putting A, I'm going to put D. Let's say atom D, it is naturally a nonmetal, so it has a negative charge, and if it reacts with BC, instead of it kicking out element B, it's going to kick out another negative charge, because negative kicks out negative, positive kicks out positive. And so what you would have here would be B bound with D, chemically bound, and then you'd have C all by itself. Alright, so we're going to look at an example, and when we're writing single replacement reactions and when we write double replacement reactions in the next lesson, we need to write out net ionic equations. So a net ionic equation gets rid of any ions that aren't actually involved in the reaction. So I'm going to take you step by step through this and then explain to you the concept of oxidation and reduction at the same time. Now this table right here up here, that's found on the next page in your notes. So this tells you that you have magnesium flakes, so magnesium, and it's going to react with copper 2 sulfate. So copper has a 2 charge. We know that sulfate has a 2- charge, and so those charges are going to cancel each other out. So you would end up with just CuSO4. Okay? So those are your reactants. Notice magnesium, when it's an ion, has a positive charge, and copper has a positive charge. Therefore, your product is going to be copper, which was kicked out, and then magnesium sulfate. Well, magnesium, when it's an ion, has a +2 charge. Sulfate has a -2 charge, and so this would just be MgSO4. Okay, so that's your first step. Your next step is to separate any compounds that are soluble in solution. So if you look at CuSO4, if you look at sulfate, which is right here, it says that sulfate is soluble. It is a soluble ionic compound unless it's bound to strontium, barium, mercury, or lead. Well, copper is not strontium, barium, mercury, or lead, so this is going to be soluble. So what I'm going to write is I'm going to write Mg plus, I'm going to break this apart now because it is soluble. So it's going to break up into its ions. So it's going to be copper with a 2+ charge, and then sulfate with a 2- charge. And then my product is going to be Cu, copper, and, well, if you look, magnesium sulfate is also soluble, so it's going to break up into its ions, so it's going to be magnesium ion and sulfate ion. Okay. Now, to write the net ionic equation, what you need to do is you need to get rid of anything that's the exact same on both sides. So magnesium, notice it's not the exact same. Here you've got the atom, here you've got the ion, so you can't get rid of that. Copper, again, here's the ion, here's the atom, so you can't get rid of that. But sulfate is the same on both sides. And so my net ionic equation for this single replacement reaction would be Mg plus Cu2+ produces magnesium ion and copper. Okay? Now the very last question here is identify the species that are oxidized and reduced. So really quickly, oxidation is the loss of electrons. So if you lose electrons, if a species loses electrons, it is oxidized, while reduction, reducing, is the gain of electrons. Okay? So the easy way to remember this is oil rig. Oxidation is loss, reduction is gain. So if you look here, if you look at magnesium, magnesium went from having no charge to having a +2 charge. So how did it do that? How would you go from no charge to a +2 charge? Well, you would lose 2 electrons. So magnesium is being oxidized. If you look at copper, copper went from a +2 charge to no charge, which means it had to gain 2 electrons, which means that copper is being reduced. And that's all there is to it. The last thing that you need to know, for a single replacement reaction to occur, you need to look at an activity series if one is provided to you, because that helps you to let you know if a reaction will actually occur. It helps us to predict if a metal is going to be oxidized. So in the example that I had shown you before, the only way that copper can be oxidized is if magnesium is higher on the activity series. So I'm going to really quickly rewrite this reaction. I'm not going to do the net ionic, I'm just going to do the reaction that we looked at before. So the only way for magnesium to kick copper out and subsequently oxidize it is if magnesium is higher on the activity series than copper. Okay? If it is higher, then it will be able to replace it. And so if you look, magnesium is right here, copper is down here, so that reaction works.